All right, now let's come to your most recent works with your colleagues.
Okay.
About what are you proposing?
Well, what proposing, and this is work that Russell Hebert is doing, and we're talking about it.
Is he your student?
No, he's a colleague. He's a neuroscientist. Is to look at the states of EEG states in the brain and see whether, in fact, this what one may call the objectified versus de-objectified states exist. And it's an interesting question, and it's an interesting assumption. And in fact, there's now increased literature in scientific literature that indicates that perhaps the alpha waves become standing or synchronized or coherent in the brain. They take place, these alpha vibrations take place over the entire brain, not just front lobe or the back. And it could be like a master frequency. It is a frequency that perhaps then is identified with the non-objective aspects of consciousness.
Okay.
You know, so awareness without objects.
Can you, in a simple language, explain objectified and de-objectified?
So objectified in this view would be awareness where you observe a cup or a flower. Say, right. This is a flower. That's an objectified sense of awareness. But is there an awareness without an object?
Uh-huh.
And the answer is yes. We know that from the Eastern tradition. Right. They call it status of samadhi, and there are different kinds of states of samadhi and different states of meditation. But now it seems that our Western science, classical neuroscience, EEG, is moving in that direction. That will be very exciting because then you have a link between the two. Between the Eastern views, let's say, and the Western scientific views.
So, am I right? Objectified is sort of outside you awareness, and
it will be objectified would be being aware of something that appears to be outside of you, quote unquote, like a flower or a table.
Yeah.
Whereas the de-objectified, but actually de-objectified is even beyond being aware, because you can be aware of your breath, and that's still an object.
Yes. I mean, anything other than the body. It's awareness, the other side of awareness.
Right. So
the body is objectified anyway.
That's right. So when I look at my hand, it's object. So even though it's mine, quote unquote.
Yeah.
So
even your thinking and everything is objectified, isn't it?
And also everything ultimately is de-objectified, right?
Okay, I get it.
The two are. So the de-objectified means awareness without the content of objects, external objects, whatever they may be. It could be the breath. It could be even the eye. I could even see my eye in a mirror, right?
Yeah.
My hand or everything. Yeah. Those are objects. Yeah.
Okay, that's great. Well, that's good. Now, let's come back to this space-time thing, entanglement and the non-locality. You say it's the same.
Well, they're not the same identical things. They are related to quantum theory, of course. They all
belong to the same domain.
They are all part of the wave nature of quantum. Yeah. So this wave nature of quantum seems to be a fundamental property that it's always there. When an observation takes place, then the waves collapse into specific outcomes that are localized in space and time. So, and a wave, in a sense, is over all space and time. Over all space and time.
Some physicists think that this entanglement and non-locality seems to belong to another kind of space, free space or something. As Penrose and others, they use Clifford's algebra or something.
Yes,
like that
Penrose particularly has done great work in terms of the.
So, is it another kind of space, like a space before this space or something?
Well, our space is three-dimensional, and then the fourth dimension is time. But in fact, there are other spaces. The superstring theory, for example, has a space of higher dimensions, depending either 10 or 11.
Do they take into account this non-locality and entanglement and everything?
Well, of course, any quantum theory of matter, including superstrings, will have to take into account non-locality, because these are definite aspects of our reality, of our universal reality. So, and has been shown in the laboratory time and again. And this was the frustration of Einstein. They're trying to get away from it. Yeah, and as soon as you have a wave nature of quanta, then you get things like entanglement, you get non-locality, and you get, in fact, the breakdown of local realism.
Yeah.
So, in fact, what Einstein was assuming is local realism,
Yeah.
which means, very precisely means that one part here in space and time does not care, does not communicate, except perhaps through the speed of light or something with other parts. The two things can be made distinct. You can separate them. But quantum theory shows that actually the two are entangled if prepared entanglement. And in fact, now new measurements by Anton Zeilinger in Vienna, at the Institute of Optics in Vienna, are very, very exciting because they go.
This is recent?
Well, Anton has been doing this for the last several years, since 1995, 96, 97. But now there's even newer results that have just come out, which not only entangles the space aspects, but now entangle the time. And that is mind blown. It blows our mind, right?
It does.
Because we are
Entangle the time?
because we are used to time moving forward.
Yeah.
So now, if you have entanglement, I use carefully the word entanglement of time rather than some might call it retrocausation. Retrocausation means that the future affects the past. And that's not quite what the story is. It's really entanglement through the act of observation of future with the past. But you don't change the past.
But, yeah.
You don't change the past. The past is defined. However, you entangle through future acts, it becomes entangled with the past. And then the past is fixed.
That's the fixed, yeah. Okay, that's